Hi, welcome to this video, how to write a Kubernetes operator from scratch, part 2. If you remember from our previous video, we started with the bare basics of how do we identify the components that make an operator, also what do we need to implement to learn from it, and what are the things that perhaps are beyond the scope of the tutorials. So let's get straight into it. We had a simple implementation, and this is available on the CN Skunkworks GitHub repository. For our operator, and we effectively wrote a runtime loop that used the Watcher API, and from that API we were able to write a pod subscription, and that subscription would tell us about any events that occurred for pods within our cluster, and we were just using a local kind cluster alongside this. What I'd like to look at today is how do we take this further to actually make these things useful, and how do we start to mimic that operator behavior, synthesizing the human element. So let's take a look at what we've currently got. So we have a runtime loop, and in that runtime loop we have a list of watchers, and those watchers would correlate to a subscription, because that subscription will return back the channel for that watcher, and we will then list through them and we will check out what's going on. What I've done offline is I've added a secondary watcher, which is for ConfigMap subscription. As you might see here on the left side of my screen, it's the same slot-in approach because it uses the iSubscription interface. This means that I can effectively write any standard library resources into this watcher loop without having to make any modifications. I say any standard, so anything off the V1 API, because CRDs, I'll show you later on, you have to import them into the project with their client set or just with their type as well. So with that said, let's have a look at what else has happened. We've got this ConfigMap subscription on the left side of the screen. It's pretty simple. You've got the struct, you have the reconcile, the subscribe, and the isComplete. And as we mentioned in the previous video, we'll do some work on the isComplete later on, but for now we're integrating it just to fulfill the interface. The big change as well, of course, is that the subscribe is actually subscribing to config maps, not pods. So therefore we should be seeing only changes in config maps within this interface. And at the top here we see config map subscription for all events is currently printed. And so here we've got a config map for all event types. And if we go ahead and look at sort of what config maps we've got in our cluster, we'll probably see that we've got the defaults that come with kind. I'm going to grab the core DNS config map just because this is a good example of something that I could delete and recreate in the cluster pretty trivially, and we'll call that core DNS.yaml. What I like to do as well is sometimes put an examples folder or a resources folder in the project, just so it's super easy for me to find it. So what I should see is if I delete the core DNS pod config map here, and we start up the debugger, well, we should see that event. And equally, when we create it again, we should see that event too. So let's go ahead and do that in kubesystem namespace. And you see there, we've got a delete event for core DNS. Now, deleting DNS probably isn't the best idea in a Kubernetes cluster, so we'll create that core DNS again. So what are we going to do today? Well, my idea was that we would try and emulate that behavior I was talking about. So let's create a config map, and we'll call this something like SRE configuration. So name SRE defaults, right? Or platform defaults. So the first thing we can do is to look to see if this platform defaults config map exists, and then within the spec we could define something along the lines of how should it look. So we could have it in our data. We could say default or annotations, and in here we could have a set of default annotations, foo equals bar kind of thing. But more importantly, like we had before last week, we could do our type SRE. And then the idea is that when the operator is running in the cluster, any new pod that starts, it'll reconcile against what it knows is good in the config map. And this is quite interesting because this will be introducing a very light level of caching in the operator, and then it will be checking against the running pods and then applying those annotations to those pods. And this could be a realistic scenario. For example, if you're using a CNI, multiple of CNI will require you to add annotations to define things like the VXLAN that they're running on, even the pod network. This could also be in relation to like IPAM, right? So you could have some form of address management that is part of this that gets fulfilled by the annotations. So that's what I think we're going to try and do today, and this should be fairly straightforward. And what I hope is the useful outcome of this is that you can see how you can start to build these behaviors beyond just the basic implementation of the loop. So let's just move these things up so we have a clean plate. Okay, so the first thing we would need to do is to define this config map, approximately sort of what we want to pull out of here and how it should look. Now, I referred to the core DNS config map. It's actually got a file that's reading from. Using the file type is fine, but of course your config map doesn't have to be structured like this. You have a couple different ways that you can structure your config map. So you of course can have things like nested JSON inside of them with a file name. You can have effectively just key value pairs as well. For the purposes of what we're doing today, I might try and keep it simple by having key value pairs. So if we put a folder in here called examples, in examples we're going to put our platform, in fact, wait, this is not a Go file, platform default config map. And now let's think about what we need here. So API version v1. We will then also put the kind config map metadata name is going to be platform default config map. Then in the data, we could put something along the lines of, annotations. And then under our annotations, we could have an array name for annotation. In fact, rather than that, we could put name. We'll call this one SRE value type. Just as a high-level example. I'm sure there'll be other ways to do this that might be more succinct, but that should do for now. And this would probably want to live in our cube system namespace. So let's put that in cube system. Now I should be able to apply this. I will go ahead and give it a go. So because I'm on Windows, I have to go through the Linux to Windows directory system. So that is in our CN skunkworks, and that's in examples, platform defaults. Okay. So I put this is again, that's an error because here you can see that it's saying, hey, data.annotations, data got an array, expected a string. So I think that the issue here is that we have an issue in our structure. I think probably the easiest thing for me to do right now is to just check out that config map I was just looking at and figure out where I went wrong there. Let's have a quick look. So that was cluster info, I think. Okay, so what they've actually done is there is a pipe, so that everything under here is an object under this kube config. So what I could do is I could effectively treat it as a string value, and then in here it could be nested JSON or something like that, or we could sort of nested YAML. I think that looks like the way they've done it inside of here. So that should be fine. So what we can do is we can call it data, and we can call this platform default. And in here we can have our annotations as if it was a normal structured YAML, and then we can come and put this in here, and we can put a couple of other examples just to test out the array. We can call this, owner CN skunkworks, and that should do us for now, and that should let me create. I might have to come back because I'll have to convert this into YAML from a string later on, but I think that's what they're doing here. So we'll come back and check it out a little bit later on. Also, I think the indentation might be a little bit off, so put that there. So let's just double check that that will create firstly. So that's okay, that will create in the cluster. And if I have a look up here now, we've got our platform default config map, and it's allowed us to put that structure in place, which is great. So I guess where I would go from here is think about, okay, well, we've got this now looping. I've created that config map subscription. How do I then check out to see what's going on with my object? And again, like, you know, I want to make sure that I have the ability to keep up to date with what this object is. So because of the way the subscription is working, we're looking at all the events on the platform for this object. It is probably worth us thinking about how would we use this as simply a channel to keep it up to date. So we have our subscription here. So first things first is I want to be able to get that config map. So let's start in a very simple scenario. You know, if config map, and we'll put probably like a values at the top here, and we'll have a default for this, and our default value will be for, and that string is going to be for the name, and we'll have namespace, and we won't call it string, we'll call it platform config map name, and our platform config map namespace just here. Okay, and then what we can do is on the reconcile, when we get our objects come through, we can identify that. So we can say that we can do it in a little utility function. So is platform config map, and we'll pass through the config map boolean error, and all that would be doing is if the config map dot name is equal to platform config map name, return a true and nil, otherwise return false and nil. We added in an error here because there are some eventualities that you might want to be able to check to see if that object is null. If config map equal to nil, we can then say return false, error, start new, empty config map. And this is one of those rare corner cases that's probably worth just handling on the off chance that we have an issue. So if is, and in fact this can be lowercase because it's not going to go outside of this package. If is platform config map, and we can say error, okay, error. If it's not okay, if error, we can klog dot error, and then we can simply return. And there's probably a few things we can do to improve that later on. However, our reconcile at the moment doesn't actually have a return type, so we're just re-returning back out. So this will now only return events for our config map. And we can just do a quick run on that. And so if I delete that config map, create it, we should see that we only get events for this. So you can see at the top, we got an add event. If I delete it, we'll also get delete event. I create it, get an add event. So nice, we've got our config map. Now, I mentioned that we're going to add a light amount of state in here. And this is an interesting one because, you know, we want to keep these operators fairly stateless, but we do want to have at least an accurate reference to what is inside the config map. So at this point in time, what I would probably look at doing would be to have a way of holding either a reference to this config map or making a copy of the config map behaviors. I think probably making a copy is the safest way. And what we could do is we could do it inside the subscription. So I like to annotate things, like putting comments in. So we'll put specific behaviors for our operator. And in the specific behaviors for our operator, this is where we define effectively the annotations. Okay, so let's say platform ConfigMap annotations. And it's okay to be pretty verbose here, I think it helps. Platform ConfigMap annotations. Now, the first thing we must do is initialize this. And there are a couple of ways we could do that. I think the most logical would be to look back at when we create the iSubscription, what happens here. It actually creates a struct, but we're not doing any sort of initialization behavior inside of here. So we have a few options. We could do it. We could even check to see if it's been initialized or not. But we'll come to that in a moment. So on the reconcile, on the added, which is the first event that will get triggered, we want to say, in this kind of event, we would probably want to make sure the map is populated. And here I can put populate the platform config annotations map. And on a delete, we would want to wipe it. Now, that's an interesting question because, again, should we be removing those pod annotations? And if we wipe it, how do we know whether we should be wiping it or not? So I think that actually might be a question mark for now. On a delete, how do we know which annotations to remove from the pod? So perhaps we need to have a flag for the phase or for the state that indicates whether we should be doing an apply or a delete. So I'm going to put a simple example before I can flesh that out properly. So platform config phase, and that could be something like an enum, and that phase could be apply or delete. So we could have platform phase, and then that could be an int, and then we could, in fact, let's do it. Let's keep this simpler because I'm just thinking rather than converting to string to int, if I'm storing this in the config map, we'll put the phase just as a string for now, and the string will have different phases. We can say apply, and these can just mirror the events. That's what I'm thinking. It's a lot simpler. Delete. Okay. And so when we first go through the reconcile loop, the first thing that happens is the p.config phase equals, and that's going to be the event.type. That event type is going to be a string of added. And that added, instead of me using a customization, it's going to be simpler if I just use the same here. So added, deleted. So if it's an added phase, we can just do a direct apply from the event onto there. We're getting a little bit of an error here, and that is because this is a type of event rather than a type of string, and therefore we can set that. And equally down here, we can set the phase to the event of deleted. Or rather, maybe rather opposed to us duplicating this, we could set the phase directly above, because it feels like we're going to need that. Although if I think about modified, I don't know if we're going to end up using modified. Okay, I'll stick with phase in these two areas. So we only want to update the phase in an added or a deleted event. So for right now, we're going to look at what happens in an added event. So I want to effectively update the in-memory definition of what's going on here. So that's when I have to start digging into the config map itself. So that would be configmap dot. Now you see we've got effectively data in here. Now if you remember what the config map looks like, that data contains this platform defaults key, and inside that key the value of that is going to come out with this bit of YAML. So let's just see if we can get that far, right? So data defaults, let's have a look. Why are we getting an error? It's evaluated but not used, so we'll call this raw defaults string. That raw default string would actually be YAML, so let's just think about YAML dot marshal, and we want to unmarshal that YAML. And we can take that out into an interface. So let's have a look. it is coming back with the type of string. So we want this actually as a byte array, and we need to unmarshal this into a type. Okay, so for now I don't have a type to give it, so I'm just going to use an interface. So unmarshaled data, which isn't a great name. I'll come up with a better one later. So we're unmarshalling that data. So we have an unhandled error. And that error we again can put an error in here, then return. And this wouldn't be ideal again, because this would keep throwing an error over and over. So let's just see how far we get, and then maybe as we go through the course of this video we can start to improve that. So let's have a look. First things first is I've not got YAML imported correctly. Now I just need to check this because I don't know if that is the actual package I want to use. So you go version 2. Okay, version 2.4 looks good. Let's use that then. And it's always worth double checking before you get started with this. So I'm just going to go get that. Okay, so let's give that a whirl. So at this point we have set the phase is added. If we go to the ConfigMap, let's have a look what happens next. So the raw string has come back, we see our annotations. Let's keep going. Now we've unmarshaled it. Now the unmarshaled interface, you can see that we have annotations, and inside of that interface you have name and value. So that's worked brilliantly. So unmarshalling into an interface is a bit of a pain because you're not really improving the situation much. And really what we want to do is have a really quick way of referencing our data. So one of the nice things we could do is to actually have a type for this. So what we can do is up here, inside of this controller, to create the operator behavior is to have an unmarshaled type. So we can call this type platform default, platform configuration. And I'm not calling it default because default's going to be the one that ships with the platform, but technically it's a platform config. That's type struct. And inside of here we can have the array, so that can be our annotations, and that would be an array of another struct, and that struct we can define as platform annotation. And so we go and call this annotations. It's going to be an array platform annotations. So at this point, and I'll just check my annotation here. So this is the library I'm using. So it says the field format is going to be tick, and then it's YAML, and then it's okay. That looks okay. So you see we've got YAML, then we're putting the annotations name in there. So we might come back to this if that doesn't work in a moment. And that annotations should match what I've got here. And then that'll be a name and a value for each one. So in the platform annotation we'll call name, string, YAML, and that'll be name lowercase, string, value, string, YAML, value. And then this platform annotations, I don't think I can put an annotation outside a struct. Let's see how we get on with that. So we'll put this as a platform annotation. And again, I'm doing this, coding this all live, so you can see this is the way I would tend to do things. I'll refer to the docs and then come back to it, and we figure out if there's any problems along the way. Okay, so we should hopefully have an unmarshaled data. Okay, so unfortunately that's not worked. I think what's happened in this situation is that it's not been correctly mapped to the symbols that I put in the struct. Another way of doing this, which is slightly more succinct, I might show you just for the sake of time, is, oh, I put platform annotation, I'm sorry, let me try one more time. It should be platform config, not the annotation that goes here. Let's try that again. And then if that fails, I'll show you the other methodology. So, fantastic. As you can see, we've now got an unmarshaled object that has the annotations in it, which is beautiful. And actually, just for simplicity, rather than then converting this back into a map, it might make sense just to store a pointer to this map. We can copy it and we can keep a pointer to it. In fact, let's simplify it. We'll do a full copy and keep a value for it. So let's set that then. So if we put the platform config, I'm just thinking the best way to do this. No, maybe keeping a pointer is better actually, because then we can check to see if it's been set. We can set the platform config, p.platform config. Where is it? It would be under p.platform config app annotations equals unmarshaled data. Unmarshaled data needs to be set here, right, and then we should be good. So let's run through this, and then on a deletion we will null it out, and that's kind of what I was thinking would be a good way of doing it. So let's see what's going on. And remember, we said on the deletion eventually we don't want to null it out, we want to actually be able to delete from the object. So it's unchanged, let's do a delete. Delete has worked, and then let's do a create. Okay, let's do a delete. Before this gets hit, I just want to show you what the current state is. We go to P, that's the current annotation object with our annotation set, and we'll be setting that down to nil, which is great. Now, one of the challenges here is that our operator isn't going to be complete until we can effectively link the ConfigMap subscription to the pod subscription, because the pod subscription is dependent on what we're updating here. And in fact, this is probably the next piece to work on, is how do we link these two things in a safe way. And so if you think what I'm trying to do is, the ConfigMap now has an in-memory object, which is the platform config, and the pod needs to get that access to that so that it can effectively keep update with what it needs to be setting on these annotated pods. There's a few ways we might go about it, right? We might share that object between the ConfigMap subscription. We might have a method in a mutex so that it could be locked and unlocked and allow the pod subscription to read from it. We could also use a channel from the ConfigMap subscription to the pod subscription where it keeps a reference to it. There are a few other ways as well, but all of these ways we have to consider the risk in terms of, will there be any kind of race condition that we're introducing? Will there be an issue in the way that we want to scale this out? Again, that's another consideration. If you now got 3 or 4 other subscriptions, will the interdependency between these two cause an issue? So I'm just going to work through this and we're going to figure this out together. Okay, so we're going to change all this. We need to change this to say fetch the required platform config annotations, loop through, and apply. That's on the add, right? That's on the add only. We haven't done the deletion event yet. So let's go through first principles on this and think about what would make sense and what wouldn't. So, well, firstly, I think we would probably, if we're going to share data between these, we could have a channel that is shared from the ConfigMap subscription into the PodMap subscription. How would that work? That channel would be effectively a pipe, and that pipe would be sharing event updates, so channel messages of the type of platform config, I think annotations is what I called it. Platform config would be the type. So we could pass those along. Now, there are some downsides to this, right? So every time that gets updated, we'd have to run an async loop with the select on it inside of here. That loop would be checking, and then that loop would have to store a reference locally. It makes things complicated because we're then having to manage this internally in the pod subscription. So I'm not super for it. I think what might be simpler for this demo is to expose this ConfigMap subscription to the pod subscription. And in fact, the way we could do that could be through the interface. We could add to the iSubscription interface something like expose parameters or expose updates or provide updates. We could also share the pointer directly into the iSubscription. So I'm going to have another think about this. So let's have a look. The way that we're actually updating this, we need to keep this safe. At the moment, they're both running in their own Go routine is another thing to consider. So you have the pod subscription and the ConfigMap subscription. In itself, that's not a problem, but we just need to be aware that when changes are made, they need to be safely reflected. So at the end of this reconcile, the ConfigMap subscription is pretty much up to date. What we could do is we could expose this so it's not just at the local level, and we could make that a field that is accessible at the platform level. But what we could also do is set a reference for the ConfigMap subscription inside the pod subscription. And so the way you could do that would be inside of here. Now, let's just have a look at the pros and cons of doing this. So first con is it's going to change the behavior inside of the run loop unless I define this externally. So let's have a look. We'll call this the ConfigMap subscription because I now need a reference to it. And that will then hoist to here. That will be removed and fulfilled here. Because I'm a stickler for things that look a little bit out of sorts, I'd rather have both of them in the same place, even if only one of them is using the reference to the other. I don't like that unbalanced nature of them. So now you see we have our subscriptions inside the iSubscription watch run loop, which is a little bit more succinct. Now the difference here would be that we're going to create a pointer specifically to the implementation of the interface. So we could try this. We'd say this specific reference to ConfigMap subscription is for updating pod annotations. And we're doing this very much naively from first principles right now. So we're going to call this pod ConfigMap subscription reference ref. In fact, it's just ConfigMap. Okay. So, danger zone. We need to make sure things are initialized. We've got to always make sure that we're putting guards in. So let's go ahead and add that in. So ConfigMap subscription ref. Now we're passing the ConfigMap in. Again, we have to be very careful because we've got effectively two objects that are initializing at the same time, but they might not have the same life cycle. one might be destroyed prematurely. So one of the things we need to do is to guard ourselves around that, and adding mutex locks is the most basic first step. We can also do a lot of checking to make sure that the object's not nil and the resource we're attempting to access is also available. So let's go into here, and I'm mentioning that because it is possible to make this work, but this can break also quite easily, and it's very difficult to find out later on when this becomes a more complex program. So we'll add some sync mutexes in a moment. So let's look at the ConfigMap subscription. So on an add for a pod, this is slightly what I'm talking about here. We want to say if p dot is not equal to nil, so subscription ref is not equal to nil, we then want to say p dot, and we're going to get the platform config annotations, and that again, I want to rework this name. It's not succinct anymore. Doesn't mean what it means. We're going to rename this to platform config. So let's change that name inside the config map and call this platform config. Rename. Okay. It means a little more of what it says now. So it says what it means, rather. Platform config. Okay, so the platform config, again, that is a pointer. We go and say if not equal to nil. So we're in a place now where we can apply this logic. So we want to say for annotation range p dot platform config annotations. At this point we can do the same logic as before where we loop through this, and again we don't want to deep copy it more than once, and you can see here I've actually done a check to see if the annotations are nil. That's from a previous video where I think we were deleting them. So at the top of this phase we will do a deep copy, and then we can add all the updated annotations. So annotation dot name equals annotation dot value, and then at the end of this we can do the update. So I will clear that out, and here, and really actually if you want to be more succinct, you don't need to update this unless there is something to be updated. So I think you could almost get away with putting this logic and the deep copy to save a cycle inside of here to update the pod, and equally the deep copy should only really be implemented if you are in this phase as well. So this is a bit dangerous running this like this, but we can give it a go. The world won't explode, we'll be okay. So what I would like to do is to prove it works. So if we go into one of these pods, if it works, it should be creating it on top of the pod, right? So we should start seeing these annotations SRE pop up, and lo and behold, we have annotation SRE, which is pretty cool. I've not had to do anything. However, where is our second annotation? The second annotation was for owner. So let's go back and figure out what's going on here. If I go to this logic, and let's run through it and see what exactly happened. And the way to run through this would be to do a delete and to let it hit the creation logic. So the first thing that's happening is, here we go. So in fact, these are going through modified events. So that is a big deal. So probably what I want to start thinking about doing is to bring this into a separate function, which is called p pod subscription apply config map changes, something like that. And in this case, we can take the logic from here. Probably don't need the event type. We will pass it, but probably don't need that. just yet. Take this down to here. And again, that object deep copy becomes pod. Okay, now we take this, this can go. I'll keep in the, I guess I'll keep it in for the information. Instead here, it becomes p.apply ConfigMap changes object runtime event. And equally, in the modified, that occurs as well. And we can, yeah, we can leave that for now. I mean, if you want to be a little bit more idiomatic, I would probably then pass pod in, save having to do the cast again, put the v1 pod up here, and delete that, and just call that pod, just to make things a bit prettier. Okay, let's start again. So we can see we had our added event. Hopefully that added event will have gone through here, and we can figure out what's going on. So I can see we have annotations type SRE. Let's do a delete, see if that comes up as a modified event. I don't see any annotations on the delete, so let's see what's going on. And the way we can do that is we can put a simple breakpoint in, and then we'll hit that. Okay, so on a modified event, let's see what's going on. So firstly, on the ConfigMap subscription ref, that has come back as nil. So let's figure out what we're doing wrong. The way I would do that is to look here. So that's not nil. Let's go through. I put 3 very intentional breakpoints there. You can see that the ConfigMap subscription has a memory address. You can see that the platform config, that is nil. Okay, so the platform config is nil at this point. Let's double check. And yeah, there is no platform config at this point, so that's cool, that makes sense. And if it's not equal to nil, we continue. Otherwise, let's get going. And I must have missed that step where I didn't reapply it. So now let's let this run for a moment. So the only annotations that are going to be on these pods are whatever we left there. So let's actually go ahead and apply. And when I do the apply, I want to put a loop in here because that's when it will next exist. So that now should be hitting this phase, and let's try and delete a pod and go through the modified event to just show that works. So this is kind of cool because we can see things as they are. So let's delete. So now we've got to the point where, yeah, it does exist actually. And what's happening here? Well, we've hit that modified. We can see that if we go into the debugger, we are getting a pointer with an address at the end of it. And inside of there, we can see our annotations. So let's go ahead and let this apply. I will allow this to apply for everything. I'll take the breakpoint out. And at this point, we should see that we get a bunch of modifications. Now, interestingly, we've got a couple errors, and we'll come back to that in a moment, but let's have a look at our pods. So you can see now we have the annotations of CN skunkworks and that type, not on this pod here. So that's, again, it's only going to occur when there's an event on that pod. So now we've got the annotation on the new pod. Right, cool. What's interesting as well is you see there's an error here coming up. And this, I suspect, is to do with the way that I've copied and then done an update on these pods. And I'll come back to this momentarily. Also, what's important is that you have to remember that every time we're updating these, it's then going through that modified loop, and the synchronicity of how you're applying that modified loop is really important. So let's just use a simple example that's not from the system namespace, because some of these have a level of protection on them. So let's take Nginx pod YAML, which is one of the most fun things to Google. We will grab the pod. I think there was a pod example in here. I will have a little bit of a check. What do we got? Okay, I think it's going to force me to write one. Okay, there we go. Here's a simple pod, Nginx latest image. That's great. So let's write this out. I don't think I need to have this second container running, but that's fine. We can roll with it. And as you'll see, we've got now a modified event on the web server in the default namespace. It'll be pulling those images, and we have our CN skunkworks owner and SRE type. Now, I mentioned a little bit around safety. So I've made it safe in the sense that I'm checking for pointers, but I'm not also checking to see if something's accessing or deleting at that point in time. I would feel more comfortable knowing that I had a way of making sure that when I'm using this or when I'm updating this pointer, nobody else can do the same thing. And so whilst we're coming to the close on this video and I want to wrap up, there is also the ability to run, have a sync mutex lock and write a function so that we can actually make that safe. Equally, another dynamic that we could have used is to have a data store inside the program so that they're using a shared accessor. Now, I'm not necessarily talking about a singleton pattern here, but I'm talking effectively of a shared resource that they can read write from. And there are a bunch of different examples of this, whether you're using an inbuilt caching system. That'll take a lot of the lifting for you. So we could think about applying some sort of memcache and sharing the memcache client between the two of them and doing a read write and letting the library take care of this. However, for the sake of this video, I'm happy that we've been able to apply some simple operator-like behaviors so that all new pods that are being created will effectively now have annotations within the cluster. There are a couple of additional issues that I'll come back and I'll do a separate version, a separate update on this, but occasionally when you get these update issues, as I said, they're synchronicity issues when you're trying to do an update to a pod whilst it's also being updated by the Cube API itself. And we need to be able to guard and build ways to deal with that, especially as you see it occurred a couple times just in this toy example. And we can do that by making sure that we're writing everything at once, and we're making sure that we're not doing multiple writes per reconcile loop as well. And I'll cover that on in a later video. I really hope you've enjoyed this part 2. We've gone pretty deep into how to make some use out of the controller and really turn it into an operator. We've looked at config maps, how to add one to our simple operator, and how to pull some value out of that config map and start applying it into a pod. As ever, please do like and subscribe. My videos, I'm sure, are full of errors and the things that I will try and make addendums on and improve over time. But as you can see, anybody can write an operator if you just take it slowly, put your mind to it, and you start to realize the value of the Client Go API and what you do and don't need in an operator. So again, thank you so much.